Hey everybody, so we're just going to go over some of the things that we did in class today and then also give you a graded homework assignment. So take your time. We're not going to give you the answers here on the video, but we are going to go over it in class the next day. Right? So the first thing that we want to talk about is what we talked about in class was when there's some situations that we think of the average as being the mean. And there's other situations that the mean is not really a fair assessment of where your numbers are. And in that case, we a lot of time use the median. So how do you know when to use the mean versus the median? So most of the time in real life, we use the mean. Okay. But when your data is skewed, when there's some really low numbers that mess up the mean, make it lower than what you have. And here's an example. Yes, there's not a whole lot of numbers. And yes, 5 and 6 are not that small in numbers compared to 9, 10, 11. But when you look at that, most of your data is like kind of between this like 8 and 12 range. And then all of a sudden you have these three numbers on the lower end, 5, 6, and 7. What's most likely going to happen is the data is kind of skewed left, which means your mean is probably going to be lower than what you would expect it to be. If I was giving a fair assessment of these are the number of writing instructions, I would say the writing instructions is usually, well, what's between like 8 and 12, maybe like 10. But when you go to find the mean will probably be less than 10. It might be something like 8.3. I'm just making that up, but let's just say it is. Well, that's not really fair. Most of your numbers are bigger than 8.3. So in this case, this would be an opportunity where you would decide that the median would be the best way to describe your data, and that would be the average that you use. Right here, and this is a good example of why. When you change your data, it doesn't, one thing doesn't really mess up the median that much. So here is a group of 10 numbers. And if there are 10 numbers and I'm looking for the median is going to be right after the fifth number, because if I break up 10 into 5 and 5, the middle of it's going to be directly between two of the numbers. So if I go 1, 2, 3, 4, 5, the median is going to lie right between 75 and 80, which means the median is going to be, 77.5. Now, if I were to take off or away this teacher wanted to take the lowest score out, by taking away the 0, all that's going to do is move the median over 1. So it's actually going to be a number in your data set. It'll be 80. Well, you can tell by removing a 0, your median didn't really go up that much. It actually went up 2.5. But when I first found the mean, I added up all these numbers with a 0 and divided by 10, I got a mean of 70. When I took away the 0, I still had a sum. When you add them all up, you still had a sum of 700. But when I divide by 9, look at how much the mean goes up. It goes up a whole 7 percentage points. So by taking away the lowest number, it shows you how affected the mean is, which is why when you have a really low number, you more than likely want to choose the median because it's not really affected by these high or low numbers. Here's a couple questions for you to answer and things that we've done in class. So think about them, look back at your notes. So first of all, these are the 5 distribution shapes we went over in class. Which one of these would you think it's appropriate to use the mean? Okay, which one of these? And just go ahead and either give the number, there's more than one, or you could actually just write in, it's actually probably better for us if you write in the actual name of it. Now that you've done that, which one of these, and there could be more than one, would it be appropriate to use the median when summarizing the data? Which one of these would be appropriate to use the median? Okay, and there could be more than one, or there might be only one. All right, so the next thing we learned in class was about variability, how spread out your data is. So you already learned how to find the MAD. That's one way that you can decide how spread out your data is. The higher the MAD, the more spread out the data. Okay? But another way, there's 2 other ways. One way we've already learned was the IQR, where you find the upper quartile and you subtract the lower quartile. So you know how to find those, but if you're given a box plot, you could actually do that by just taking this number. This is the lower quartile, and this is the upper quartile. Lower quartile and upper quartile. Well, a third way that you could find out how spread out the data is probably the easiest way is the range. Range is just the highest or the maximum minus the minimum, which is the lowest number. So in these two box plots, we'll call that box plot A and box plot B. If you found the range, the lowest number subtracted from the highest number, you would do 20 minus 3 and get 17. That's the range. This one has a lowest number of 3 and a highest number of 20 as well. So this one also has a range of 17. Now, so before you say that, ooh, these two have the same variability, you also want to make sure you look at the IQR. And in this case, if you notice the box itself, this box right here is a lot more spread out, a lot wider than this box. Well, that means that your data, even though they have the same range, you could consider this one, box plot A, to be much more spread out or much more variable. So after you check the range, you always want to check the IQR, the interquartile range, because this is telling you that 50% of your data is between 9 and 19. That middle 50% is between 9 and 19, which is an IQR of 10. This one has an IQR. Your middle 50%, half the people, or I don't know, actually this is a length. Half the lengths are between 5 and 19, which is an IQR of 14. So even though they have the same range, the fact that the IQR is less means that this one, box plot A, is much more variable, is a little more spread out. But always check the range first, then check the IQR. Okay? So these two box plots, box plot A and box plot B, have the same mean and they also have the same MAD, but we still want to compare the variability. So right now, first thing I want you to do is, can you tell us what the variability of A and B are? The IQR, excuse me, what the IQR of A and the IQR of B. Now what I want you to tell me is, what is the range of A and what is the range of B? And tell us both in those boxes. Okay, go ahead, write that in. And now, would you say box plot A or box plot B is more variable? And can you tell us why? Don't forget to tell us why. Okay. Now, a couple more questions. Actually, I think this might be the last question. Nope, one more question after this. So I want you to look at Claire and Lynn's statistics. And in a sentence, I want you to look at their MAD. I want you to look at the IQR for each of them. I want you to tell us in a sentence which one you think has a higher variability. Which one of these statistics do you think is more spread out? Okay. And the last question we want you to do is, can you find, looking at this data, can you find the MAD of this data? Which is, of course, the mean absolute deviation.